In the dry lands of Pakistan, there are villages where clean water has always been precious. The soil is dry, the wells are empty, livestock struggles to find enough food. Many families depend on extremely limited water sources. Without water, there are no crops. Without crops, there is no stable work. And when this situation continues for years, water scarcity is no longer just an agricultural problem. It becomes an economic problem, a social problem, and, eventually, a security problem. Pakistan therefore came up with an enormous solution. Instead of moving people closer to water, they decided to bring the water to the people. Water is taken from the Indus River system at Taunza Barrage. From there, it travels through Punjab, then continues toward Balochistan. The entire Kachhi Canal system was planned to extend for nearly 500 kilometers. Its purpose is to carry water across some of the driest parts of the country and create a more reliable irrigation network. The canal is especially important for districts in Balochistan, such as Derabugti, Nasirabad, Kachhi, and Jalmagsi. These areas have long faced irregular rainfall, water shortages, and limited irrigation. By bringing water from the Indus River system, the canal can reduce the impact of drought, support agriculture, provide water for livestock, and give farming communities a better chance of surviving long dry seasons. In Punjab, the system also supports agricultural areas in Dera Ghazi Khan and Rajampur. So the Kachhi Canal is not simply moving water through the desert, it is connecting entire districts that once depended heavily on rainfall to a more reliable water network. But the most remarkable part is that much of this water can move through the system using gravity. No need for thousands of pumping stations running continuously. No need for a giant network of engines. Only a carefully controlled slope. And this is where everything becomes difficult. If the canal is too flat, the water moves too slowly. Sediment begins to settle. The canal bed can gradually become clogged. But if the canal is too steep, the water accelerates. The energy of the flow increases, and that same water can begin to damage the structure itself. A very small error at the beginning of the canal can become a very large problem hundreds of kilometers later. If you enjoy seeing engineering projects like this, subscribe to the channel now, because the hardest part is still ahead. Once the route is confirmed, construction begins. Survey teams establish the canal centerline. Every change in elevation matters. Every section of terrain must be measured. Then, excavators remove layer after layer of soil. Bulldozers shape the canal slopes. Graders refine the elevation. Heavy rollers compact the ground. Meter by meter. A massive trapezoidal channel begins to appear in the middle of the desert. The shape is deliberate. A broad, flat canal bed carries the main flow. The sloping sides help stabilize the earth. Raised embankments provide extra protection against overtopping. And along important sections of the canal, a service road allows inspection teams and maintenance vehicles to reach critical structures. But digging the canal is still not enough. If water flows directly over bare soil, some of it will seep into the ground. The flowing water can also erode the canal bed and its slopes. So, important sections of the canal must be lined with concrete. The foundation is prepared. A granular bedding layer is placed over the ground. Forms and guide rails help control the shape and thickness of the lining. Concrete is poured across the canal bed. Then along the sloping sides, the surface is finished to create a smoother path for water. But concrete cannot be poured as one endless slab. The intense heat of the region causes concrete to expand and contract. So, the lining is divided into separate panels. Construction joints and contraction joints are placed between them. Flexible sealant is used to reduce leakage through those joints. Then comes curing. Because under the intense heat of Pakistan, fresh concrete must be protected before water is allowed to pass over it. Only after the lining reaches the required condition can the forms be removed. The canal bed is cleaned, and the project moves to the next challenge: controlling the water. Large reinforced concrete regulators are built at strategic points along the canal. Between them are large vertical steel gates, motors, gearboxes, lifting shafts, hoists, and control systems. Everything works together to control the flow. Raise a gate slightly, and more water passes through. Lower it slightly, and the flow decreases. Control the gates, and you control the entire system. Sensors monitor gate positions. Water levels are measured. Electrical systems power the equipment. Earthing and lightning protection help protect the installation. Technical lighting allows operators to work after sunset. From above, the canal may look simple, just a blue line through a dry landscape. But behind that line is an entire hydraulic control system. The canal does not only have to survive drought, it also has to survive floods. That sounds strange. A desert struggling with water shortages can still face dangerous flash floods. When heavy rain falls in the mountains, seasonal torrents can rush across the landscape. They can cut directly across the canal route, damage embankments, carry away soil, and cause severe erosion. So, engineers build cross-drainage structures. Heavy rock protection helps resist erosion. Sky banks direct floodwater, and protected drainage routes allow natural runoff to pass safely across the canal corridor. The system also includes emergency escape structures. If the water level inside the canal rises too high, operators can release part of the flow into a separate escape channel. But water leaving a control gate carries enormous energy. So, an energy dissipation structure is used to slow it down before it reaches the natural outlet. The goal is not simply to move water. The goal is to move water safely. The canal must also cross roads and existing infrastructure. Bridges connect both sides of the corridor. Culverts maintain drainage. Service roads allow workers to reach important sections. Everything has to function together without interrupting the flow of water. But one main canal cannot irrigate hundreds of thousands of acres by itself. So, the system divides. From the main canal, water enters branch canals. From branch canals, it moves into distributaries, then into smaller, minor canals, and finally, into watercourses that carry irrigation water toward individual fields. The farther the water moves through the network, the smaller the channels become, but the distribution becomes more precise. Water is divided, measured, controlled, and delivered to the places that need it. But this is only the engineering story. The Kachhi Canal faced another challenge: security instability in Balochistan. Part of the route passes through areas that have experienced conflict for many years. In those places, engineers and workers could not operate like they would on an ordinary construction site. The Pakistan military, therefore, played an important role. On one side, security forces protected the project. They established checkpoints, conducted patrols, protected engineers, protected workers, protected construction equipment, and helped secure movement through high-risk areas. On the other side, military engineering units also took part directly in construction. They helped open access routes, excavate canal sections, operate heavy machinery, build flood control structures, prepare foundations, and construct important parts of the project. One force protected the worksite. Another helped build the project itself. That created a very unusual construction environment. Excavators digging into the desert, trucks carrying materials, engineers measuring the route, workers pouring concrete, and security forces protecting the entire operation. If you find this part interesting, leave a comment and tell me, what do you think was more difficult, the engineering challenge or the security challenge? What makes this project even more remarkable is that it was not built during a completely stable period in Pakistan. For more than 20 years, the country went through repeated periods of political change. Governments changed, national leaders came and left office. Funding was sometimes delayed. Construction slowed at different stages. Material costs increased. Security conditions changed. But one thing almost never changed. Pakistan continued pursuing the project. From one government to the next. Machinery could stop. Funding could slow down. One government could leave office. Another could take its place. But the project continued. That is what makes the Kachhi Canal remarkable. It is not only an engineering challenge, it is also a story about persistence. A project that had to survive political change, security problems, financial pressure, and the passage of more than 2 decades. Yet the goal remained the same: bring water from the Indus River system to the dry lands of Balochistan. After years of construction, critical sections of the system were finally ready for inspection. But water could not simply be released into the canal. First came the dry inspection. Construction debris had to be removed. Concrete panels were checked. Joints were inspected. If a defective section was found, it had to be marked, cut out, cleaned, and rebuilt. Then came the mechanical tests. The main gates were tested. The escape gates were tested. Branch gates were tested. Motors, hoists, sensors, power systems, bridges, service roads, safety equipment, everything had to operate as one connected system. Only after those tests were completed could the most anticipated moment finally begin. Water, a control gate, was lifted very slowly, not all the way, only a small opening. The first thin sheet of water began to pass underneath. It touched the concrete surface that had once been completely dry. But the engineers did not fully open the gate. They waited. The water level was kept low. They checked for leaks. They inspected the joints. They watched for seepage. They looked for erosion. They monitored the canal for unexpected movement. Only when everything remained stable was the water level slowly raised. Then, water began leaving the main canal. It entered the branch canals, then the distributaries, then the smaller channels. One gate opened after another, section by section. The network began to come alive. From above, it looked almost like a circulatory system, slowly filling with water. Every kilometer the water advanced meant another piece of dry land had a chance to receive a more reliable water supply. And then, the most important moment finally arrived. Water reached the fields. At first, there was no miracle. The ground simply changed from light brown to dark brown. But after repeated and carefully controlled irrigation, the first green shoots began to appear. A tiny plant may not look extraordinary, but in a region where water determines whether agriculture can survive, it means something completely different. As water moves deeper into the canal network, the impact of the project begins to spread. Families have a better chance to maintain stable agricultural production, especially in cotton-growing areas. With a more reliable supply of irrigation water, farmers can cultivate land more consistently, and that means work. Planting, crop care, harvesting, transportation, processing, and other jobs connected to agriculture. As production expands, the cotton fields can also become more mechanized. Machines are brought in to prepare the land, support planting, assist field operations, and help with harvesting. Agriculture no longer depends entirely on manual labor. After harvest, the cotton moves to processing facilities. The seeds are separated. The cotton fiber is cleaned. Then, it is spun into yarn. And this is where the value of the canal becomes much larger than the canal itself. A stream of water begins in the Indus River. That water enters the Kachhi Canal. The canal delivers water to the fields. The fields produce cotton. Cotton creates jobs. Then comes processing, yarn, textile production, trade, and exports. Cotton is one of Pakistan's most important agricultural commodities. So, the Kachhi Canal is not only about bringing water to dry land, it can also support an entire economic chain, from irrigation to farming, from farming to mechanization. from mechanization to processing, and from processing to trade. For farming families, the difference can be enormous. Reliable water can mean the difference between a failed season and a productive one, between land that remains dry and land that can support crops, between unemployment and a local agricultural economy. If you want to see more mega projects that can transform entire regions like this, subscribe to the channel and turn on notifications, because this is only one of many extraordinary engineering projects around the world. The Kachhi Canal does not truly defeat the desert. It simply creates a path precise enough for water to reach the places that need it. Behind that flow of water, there is concrete, there is steel, there are machines, there are engineers, there are workers, there are military engineering units, there are security forces, and there are more than 20 years of commitment to a single goal. A country changed governments, leadership changed, construction slowed, security conditions changed, but the water project continued, and in the end, people did the hardest part: surveying the land, excavating the desert, pouring the concrete, building the gates, protecting the construction sites, testing the system, and maintaining the network. Then, gravity did the rest. A stream of water begins in the Indus River. It travels across hundreds of kilometers of dry land, through regulators, through branches, through smaller channels, until finally, it reaches a field. The soil becomes wet. The first green shoots appear. Cotton begins to grow. Machines begin to work. Families gain jobs. And a dry region becomes connected to a much larger agricultural economy. That is the Kachhi Canal project.